Hi guys, I'm really sorry about that. Having some technical issues, and we're trying to improvise a way to do this. Um, so basically, my name is Jason Phelps. I'm a Gensco DSG. I am one of the newer guys to the team, so this will be the first time that I've ever run through this training, and I'm doing it on somebody else's computer. So might be a little bit awkward. Please don't hesitate to raise a hand, ask questions, put stuff in the chat bar. This is not going to be a fast-paced class or anything along those lines, but I do have 28 people in here. So, throw it into the chat. If I can get to it right off the bat, I definitely will. Um, but we're going to jump right into it. So, Diamond System Builder, basically a little bit of background on it. It is a program that Mitsubishi put out there in order to help design and properly size. It doesn't do heat load calculations or anything along those lines, but it allows you to verify that you have the correct size equipment built into your system. It is a great sales tool. It is one of those things that whenever it comes to larger product projects, especially, I truly recommend having it available to almost everybody that's working on the project so they can update as needed. So we're going to jump right into it and we're going to start a new project. I'm going to open up my chat bar here so that I can see anything that comes in and deal with it. I believe Aaron is on here as well too, so he might be jumping in occasionally and throwing a few things out there. So as you open up Diamond System Builder, this is the home screen that you're going to see right off the bat. It is going to update with all of the projects that you build in it and anything that is shared to you. As you can see on this bar across the top, we do have a large server that is attached to this. And rather than emailing things back and forth and things along those lines, you can go directly to share and you can send it to anybody that has a login on here. Again, I do recommend anybody that is working with it have an individual login rather than a company login and sharing projects that way. We'll get into that a little bit here in a little while. So as we start a project, the first thing that we're going to do is we're going to click the new project. Under almost all circumstances, we are going to go into design build rather than plan and spec. If you are building anything with a central controller, your your design function right here. The first few that I'm going to do are going to be smaller residential systems. So we're going to go ahead and do it without central control. Model generation over here, we have our old generations. If you're checking an old system for compatibility for charge calculations, anything along those lines, you can go in there, but 90% of the time we're going to just leave it on both. Default brand is Mitsubishi Electric. Default display is going to be model number. You also do have a marketing name on here. Most of us do not use that, so I recommend leaving this on model number as much as possible. Along this column, 60 hertz is going to be the standard in America, so unless you're designing something for out of the country, we're going to leave it right there. Then we have R22, R454B, R410A, and CO2. Project 8, that is going to be one of those things. I'm going to go ahead and stick straight to the R454B projects today just because there are a few changes as far as room sizing and all of the other things that need to be taken into consideration whenever you're designing the 454 system. So as we go in here, we do have the ability to change the connectable capacity. This is not the actual capacity. So in a lot of cases, in almost all cases, what we're going to see is people are going to use this 130 to 150 maximum capacity or maximum connected capacity. And Some circumstances, guys, are using the 200%. If you want the most accurate sizing, then you want to go to 100%. That is going to limit the amount of indoor units that you can attach to an outdoor unit to only 100% of the capacity. If you're doing anything with heat recovery, larger VRF systems, things along those lines, then you're basically you can have partial demand on here. D rates, always leave those set to 1.0. Update units of measurement. If you are using metrics in a system or anything along those lines, you can actually get in there and change that. This is a very important tab that a lot of people forget about here. And these are your design conditions. This allows you to go in there and manually change your design conditions if you would like to do it that way. In most cases, people are coming in here and they're selecting from the area that they're designing from. In this situation, we're designing for Washington just because that's where I'm at right now. And I'm in the Seattle area, and as you can see, it is changing these design conditions to kind of what we know to be the design conditions right here. So you can set those up as standard profiles. You can edit the name, you can add these as you want to. I haven't found any need to do that personally because it's quick enough to get to it anywhere that we want to. We'll get into the submittal package and the extended warranty after we start building out the project, but for right now, we are set up to design a system here in Seattle, Washington. And one of the great things about DSP is it is going to basically stop you if you make a mistake like that. So after we get through there and we get everything all built up for our design conditions, we're going to have a selection of potential outdoor units. And in this situation, first one that I'm going to build out is I'm going to build out a 1-to-1 P series just to show you guys how simple this actually is. So in this situation, we have no IMNET on here. We are going to go ahead and throw in, let's go ahead and do a Hyperheat outdoor unit. So this is a 3.5-ton outdoor unit. Unit elevation, we're going to put this in the backyard at 0 feet elevation. And our A dimension, we'll deal with that after we go ahead and do our indoor unit. If you have a tag number or anything that you need to go in there, we can name this ODU-1 if we like. This is going to come into play if we have a situation where we have to verify warranty or verify a startup for warranty situations, things along those lines. Mostly only on commercial projects, so we're not going to worry about it right here. Potential accessories that could be attached to this are all going to pop up in here. You know, if you're building a bill of materials to go in for an order or something along those lines, this can actually be very useful. In this situation, we're not going to do any of that. We're going to go back to our unit information and we're going to click OK. And in this situation, basically we need to have at least 25 feet on here if we don't want to deal with noise issues. So this is going to bring up our outdoor unit up here in our field of work. And in this situation, we're going to go ahead and do this. Like I said, this is a 1-to-1 system. So I'm kind of looking at this as if it is going to be an air handling unit here. So our potential matches are going to show here. If you didn't see what I did right there, I just kind of drug the multi-position air handler over to the little dash box over there. That's going to go ahead and populate all of our potential 1-to-1 units that we can have in here. And if by some odd chance we grab the wrong one, we can go up here to the type and we can actually change to any of the other three that we need on there. Again, we can go with marketing name or model number. All of us work off of model numbers. So the only potential match here is going to be that PVA 42. This is where we start seeing some changes based between the 410A systems and the 454B systems. Our piping length here, like I said, we want to do a minimum of 25 feet. So we're going to go and we're going to go 29 feet here. We're going to say we've got 3 bends and the zone mounting height. Let's go ahead and say that this is a horizontal left ceiling suspended in a garage, and we're going to hang this at 9 feet. Unit elevation is going to be 9 feet as well. That one with a 454B, we'll see if that is necessary. I'm going to go ahead and delete that just to see if that winds up being necessary. And a standard garage size, let's go ahead and call this a 15 by 24. We've got, since we're in a garage, there's going to be 0 conditioned space. And that 15 by 24 garage winds up being 360 square feet. The room height, let's call it 10 feet. And we are not installed in a conditioned space. We can add a room here and we can call this the garage. And we don't have a group because this is a one-to-one system. There is no MNet address because once again, this is a P series one-to-one. If we wanted to actually do a serial number in here, we could, but in this situation, we don't need to. But we did do a tag on the outdoor unit, so we're going to tag this as AHU-1. So in this situation, the condition space area is too small. Increase the condition space area through the additional space connections or ventilation opens to 172.3 feet. Oh, okay. So I actually made a mistake here. So the condition space that we've got, they're looking for the square footage of the house. So this is going to be a 1,400 square foot house. So unit elevation must be specified. I thought I had that in there. Oh, I did it. I did it in the wrong spot. So we've got that there. So now everything's going to come across here. So on a standard one-to-one, there's a little bit of information that you're going to need to have on there. So whenever we look at the quick results over here in the right-hand column, this is going to be a lot of the information that we need. We've got a one-to-one system. Capacity is 100%. Total piping length is 32 out of 245 possible feet. That 32 32 feet takes into account the bins that I put in there. System refrigerant is the 454B. Additional field charge is 0 pounds, 0 ounces. So in this situation, we can have a lot of charge. This particular one, I believe, is charged up to 50 feet. So let's say 55 feet here. And we still have no additional charge needed on here. So let's kick this out even further to say we wind up, the homeowner decides that he wants to do the outdoor unit way out in the middle of nowhere and pipe underground. And we're going to increase this out to 150 feet and we're going to throw 12 bins at it. At that point, we start seeing some additional charge calculated in here. So a few of the other numbers that I definitely want people to understand here, especially whenever we're dealing with ducted systems, we see occasionally people come back in with, it's not performing the way that I expect, having customers wonder whether or not it's the system that is that is derating, or if they've got something going on with their installation, or if they have an incorrect charge. One of the things that we wind up getting into is going in here, and you can actually calculate the BTU output out of this relatively easily, and coming back in here, building your system in DSB and checking to see if you're putting out what our system is expected to do. It winds up being one of those tools that does come in handy in the field. And I wind up doing on site visits, I wind up building a lot of these systems out whenever I'm in the field and looking to see if people are getting the BTUs out of the system that they should. Because if we're not getting the BTUs that we're calculating here, then we know we've got something else going on with the system. So we're going to go ahead and scratch this system at this point and take a look at a couple other scenarios. So we're going to build a new project. We are not going to save this one because these are just scenario builds. If you are building for design, and I do recommend doing a DSB on every quote, every anything that you do, most certainly needs to be done. And as we get into some more of these more complex issues and systems that we're going to be building, we're going to wind up using a lot more of these buttons on the top. This being a one-to-one system, one of the more important tools that we can look for is the global check here, and it's going to tell you, any possible defects that you could have here. So, in this situation, I never assigned a remote control to it. We can go through there and we can actually hit the accessories wizard, or the controller wizard. I apologize there. And we can go through here and we can say we're going to throw an MHK2 on here. And then it's going to basically tell me that all checks are performed successfully. All right, we'll save that one. So in this one, we're going to go through and we are going to go back into our design conditions. Let's look at a build in Montana. And I'm going to be in Missoula later this afternoon, so let's go there. We've got a little bit more extreme design conditions here. So we've got -13s on the heatings, and we've got cooling dry bulb all the way up to 92. So there's some pretty extreme conditions here. So we're going to go ahead and we're going to do a smart multi in this. We're going to go ahead and look at a 4-ton hyperheat because we got those super cold conditions out there that we're going to have to address. Whenever it comes into the smart multis, we have a few more options up here that populate. We have MNET communication, no MNET. We have single phase, we have 3-phase units. We have MMP indoor units or city multi-indoor units. One thing that a lot of guys don't seem to know about the smart multis is at this point we can't actually put city multi-indoor units on there. And that allows us to get away from using the branch box. But for this particular one, I'm going to look at this as more of a residential, and we're going to go ahead and go with MMP. We're going to include all of our port adapters. We are going to go ahead and say the outdoor unit is going to power my branch box. We're going to install this at 0 feet. And that address is going to be 51 because this is going to be a single outdoor unit system. And I'm going to go ODU-1 because even in residential, I name all my units. So here we wind up with a couple of options. I'm going to go kind of big on the system since we've got a 4-ton outdoor unit. And my first joint that we're going to go ahead and throw in here is we're going to do 2 branch boxes, and we're going to go ahead and throw in a joint here and we're going to go about 10 feet away from the system. We're going to do that fairly straight and not wind up with any bends. So as you can see on here, the T is not bullheaded. We don't want to ever bullhead that T if we wind up doing these. I've ran into that a few times in the field, and we'll just the heads up on that. But we're going to do 2 3 branch box systems, and the first one's only going to be 6 feet away with no bends again, and we're going to hang it at 10 feet. And then our second of 3 is going to be here, and this one is going to be 35 feet away, and no bends, and a 10-foot elevation as well. So we've got these two up in the attic. So at this point, we've got a 4-ton system, 2 branch boxes, and no indoor units. So we're going to go ahead and we're going to do this kind of a mix between wall-mounted units and indoor and one-way ceiling cassettes, because that's a installation that I see fairly commonly. So we're going to do a couple of FS06s coming off the branch box to this first one. We're going to go 12 feet, no bends. Unit elevation is going to be at 8 feet. Floor area in this room, let's call it a 10 by 10 room. So we've got 100 square foot. Room height is going to be 9 feet. And we can call this bed 1. Now, a 6 is going to be relatively large for a 100 square foot bedroom in most conditions. Like I said, this is Montana, so we're going to say we've got some bad inflation. Mnet address on this is going to be 01. And then we're going to have, let's go ahead and go with a 9K in the master bedroom. Got 25 feet there. About that at 8 feet. 120 square feet. Mom and dad have a high ceiling. We're gonna do and then down here to the other branch box, we're gonna go, let's go ahead and say we're gonna go ahead and do a wall mounted 1-ton. It's gonna be 6 feet out. 0 bends. Unit elevation is going to be at 8 feet. Floor area. This is a kitchen, so let's call it 100. Let's call it 150 square foot, and room height is going to be 10. And then let's go ahead and call this, and we're going to end cap these last 2 zones. So this is going to give you some real world conditions here. So as we went through and we did the design conditions, we can see that the possible heating output out of this 4-ton system is going to be 49,000, basically 49,000 or 49,000, almost 50,000 BTUs. So in bedroom 1, we've got a heating potential of 8,100 BTUs, which is going to be really big for that 10 by 10 room potentially. So this can help you can help you see some of those situations that you might wind up running into as far as overshoots, things along those lines. But one of the things that whenever I was in the field and working, both sides, sales and install, I would actually put this into my proposal to a homeowner. not only does it help to add a lot of validity to your proposal, and it shows that you're putting a lot more thought into it than just every other guy on the block that's pencil whipping a quote and saying, I just had somebody come in with a question asking, do the 6K heads ever have a heating discharge higher than 90 degrees? I've never found that on DSP, and it makes me upsize even in little rooms because I'm in Montana and my customers are wanting heat. So you will not usually see them go over 90 degrees. Ideally, ideally what we're doing in these designs is we're building a system that is going to maintain a temperature rather than having somebody that wants to feel that 110 degree discharge temperature that we're used to on gas fired appliances. So you will see it sometimes. We can change this scenario over here, and we can look at, let's go ahead and switch this over to a one-way ceiling cassette. And at that point, you will see that you will actually get a little bit more temperature, that heating discharge temperature out of there. So, you can play with that a little bit, and you're not necessarily going to see it on the 6K heads. There might be one or two on here that you can get it out of. I have personally measured a few of them at over 90, but that is one of those things that I don't see it a whole lot. So if we go, I think originally I had the FXNL in there, and yeah, that drops me down to a little bit below 90. But if it is something that you're looking for, using the DSB will allow us to, yeah, I mean, you can see there is a couple of degree difference between the FX and the GX. So, but as you get into the larger heads, you will see this number go up over 90 degrees. And like you said, you are oversizing it. It's not necessarily ideal to do that. And one of the reasons that we wind up seeing that it's not ideal to do that is, that short cycling of the system. And if they want that initial heat and it comes on and it blasts them with 90 degrees, but then it has to shut off 2 minutes later, we're going to have a hard time maintaining that temperature. It's going to just cycle on and cycle off and cycle on and cycle off, rather than teaching and letting your customers know that in an ideal situation, they're going to set a number and maintain the temperature in that room rather than blasting that hot air at them. So hopefully that answers you. So as we go through all of this, like I said, I went ahead and capped this out. Our connected capacity here right now is, we're at 87.5% of our connected capacity. So we can actually, let's say we want to go ahead and add another, we've got a bonus room that we want to add in here. So we're going to throw a KX09 in here. And this one's going to be 25 feet. We're going to mount this at 1 foot. And unit elevation is going to be 0. And this is just a little bonus room, so we're going to call this at 95 feet. Room height's going to be our standard 10. And we're going to call this billiard room or something. I actually had to do one of these not too long ago. And we can go back and add tags later if we wanted. So once again, this is going to give me that little pop-up saying that there is the potential that on a 454B system, that this room does not have enough floor area. So we need that floor area to be 96.9 feet or 96.9 square feet. I'm not going to get into a whole lot of the 454B updates. This is more to show you what happens and how this catches those. But that indoor unit, the floor area must be 96.9 feet. So this room is a hair small. So undercutting the door, putting a louver in a door so that you've got proper conditioned space can actually allow you to overdo that and include those rooms onto the square footage. So since we've got a room that we can actually go ahead and louver this into, let's go ahead and double this out, or a little bit more than double this out. And we're going to say that that became a part of the hallway that's feeding it. Now it's 180 square feet. So we're good to go there. But at 95 feet, we are really, really close to the amount of area that we needed. This one actually pops up at only 96.9. So once we break into and undercut that door and give up a little bit more of that floor area that we can consider conditioned space here, we're good to go. But what I did here is I actually exceeded the total capacity of this unit. So that 1 ton there, or that 3/4 ton, is too large to go on here, and I don't have any other options. So it's going to stop you from putting together a design that will not allow you to go ahead and sell this system the way that you might have additionally thought. So again, we're going to go back up here to the accessories and the controls wizard, and all of these are going to need some sort of controller. So we can actually go in here and we can go in here and say, we need a condensate pump. That's going to generate it on your bill of materials if you generate one later. Or if you need disconnect switches to get into um, your municipality might require it, or whatever the case may be. Um, Advanced, we're not going to use that. But we're going to go back out here and we're going to go back and we're going to go to controller wizard, and we're going to, on certain ones, we're going to go on built-in controllers, and we're going to assign this to basically all of these are going to have the potential to be controlled by the built-in controller. So we're going to go ahead and we're going to have this group 3 over here. We're going to go ahead and add a MHK2 to that one. And I missed an MNAT address in here somewhere, so we can go back in here and we can double check that. The second number right here is what you assign as an MNAT address. So I missed it right here. So my MNAT address here is going to be 4. Catches me there, and we're going to go back and do our global check again. So all checks are successfully performed. We have any necessary controls that we need or anything along those lines. And we're going to come over here, and we could have had up to 8 indoor units here, and that's the max that you can really get to if you're not doing city multi indoor units. If you need more heads, then we can do city multis. I believe off the top of my head, I think those will do 16. We've got 117 total feet that we used out of 492. Our furthest is 51 feet, and we didn't have a whole lot of bends in there. On a small system like this, we were able to hand bend everything, so not register anything as a bend. So our charge here, additional field charge, is going to be 13.82 pounds. As if you've installed any of these outdoor units, they come from the factory just charged with enough refrigerant in order to basically fill this system. So we're adding here is the refrigerant for the entirety of the system. So that gives us a total charge of 20.43 pounds. The floor area, we have actually looked at all of that kind of as we went through. So we're actually only gonna get about a 0.970 rate, which is pretty darn good. And so if you've got a house that fits these needs, if you've got a house that actually comes back with, right around that 4 ton actual cooling load necessity, this is actually an ideal system. And each one of these rooms, kind of like we were pointing out with this FX09 and this small bedroom right here, that's almost an 11,000 BTU output. That's pretty substantially oversized in most conditions. So it is one of those things that should be looked at, whether or not it's something that you choose to address or anything along those lines. We're gonna go ahead and look at it from the perspective of what your customers' needs are the most. But the rest of these are would be, pretty close to what we would see in a real world situation. And if we do change this back to an FX09, FSX06, because we're not really worried about that 90-degree discharge temperature, we go back through here. And still, we've got a pretty dramatic oversize for that bedroom, but walking into it knowing what's going on and knowing the limitations of the system is going to be there. So again, since you changed it, go ahead and do your global check. But at this point, let's go ahead and do, uh, in a lot of cases, I'm dealing with commercial jobs. So we're going to go ahead and kind of do a small commercial job. Let's call this, we're going to look at Bend, Oregon here. And again, we got some -0 or -3 on our design conditions. And this is going to be a central controller. And I have missed that twice now, so we're going to go ahead and kind of go through everything here. So we are going to go with a central controller here, 454B, that's BC Electric, design conditions. And we're going to go ahead and look at a heat recovery system here. So our outdoor unit that we're going to go in here, we're going to call this a relatively, let's go with a twin system here. This is a 12-ton system. And we're going to set these both at 0. And our MNET address is going to be 51. A dimension is going to be 24. inches. And our C dimension, we're going to do one bend on this, one bend on this, and we're going to call our C dimension out there. We're going to go 8 feet to our splitter. So our system as we build here, so this is going to be a fairly big system. We're going to have a main and a sub controller. We're going to add accessory ball valves to all ports. That way, if they ever do decide to do any additions, we're going to go along those lines. We've got no bends here. We're going to hang this at 15 feet. And that address, I'll go ahead and address all these later. And I'm just going to go ahead and throw some stuff in here, and we're going to call and we're going to go ahead and copy this component, and we're going to go ahead and throw all of these in, and we're going to go ahead and edit this to IDU2. And we're actually going to leave that in office one, and we're going to do kind of a large cubicle type of area. And we're going to put all of these into one group and have them all be controlled by one controller. And then we're going to go ahead and come in here. Oh, so we're going to go ahead and not do that. And we are going to go ahead and go in with a ceiling concealed ducted. And this is going to be our, say this is our bathroom group. Actually, let's go ahead and do that. So we're going to have one ducted unit feeding both bathrooms. And we're going to mount this at 15 feet as well. Piping length is going to be feet. So at this point, we've only got, actually, this should have been. This is going to be a 3-ton. Packing area. And you can see that it is actually closed off this port because we're actually working up into the capacity of what we can actually add to this particular unit. So, and then we're going to throw 4-ton in here. Piping length on this one is going to be 155 feet. We're going way, way over here. We're gonna have 3 bins here. 15 feet. And this is going to be retail. Okay, and then we're going to go ahead and go back through here and we're going to go ahead and set in that addresses on here. And as you can see, it populated all of those and it's given me what it believes all of the addresses here should be. And on a system like this, it's going to go ahead and assign it to the lowest possible number. If you are doing commercial systems and you send your guys out with a system that is already pre-addressed and they decide to address it different for a different reason and they have access to this, they can update it. And right now we're kind of designing a system. So we're going to go back through and now that we have all of this stuff installed and our installers have come in and said, well, this one actually wound up being a 32 feet line set. And you can see our additional charge right now is already at 26.2. As we add that, now it's gone up to 26.52. And this one was actually only 7 feet. And this one allowed us to go out. And this one we had to route kind of differently. So it wound up being 35 feet. And it's going to keep that additional field charge updated. And your guys in the field can make this without calling into your office and having them, having your engineer or anything update everything. And this would be a live document. So if they're updating it, everybody that has access to this is going to see these changes that get made. So whenever we come back in to do the startup and we have this live system and I can pull this up and I can say, okay, cool, there's all of that. We are, we can double check all this and then we can verify that we've got exactly what we need here. And we can say, okay, so total charge that went in was 27.5 pounds. We should be good to go. And then we're going to go ahead and we're going to set group by location. And like I said, this was all groups right here. Controls view right here, group 1. So we have all of these controlled by 1. And we're going to go ahead and go in with an MA controller here. Actually, we'll do that here shortly. And we're going to add that. And these guys are going to be controlled. That. Well, those here. And then whenever we go back over here, we see that these are all, these have a built-in controller at this point. There's our piping view right there. Equipment view doesn't change. Well, doesn't change anything, but it basically builds out that bill of materials that we would need to send over in order to get, why did that give me an MHK1? Let's go back over here. Oh, I'm gonna talk to the guys about why this is still throwing MHK1s in instead of MHK2s, because that's a little bit different there. So we can go back over here and we can create a submittal package on this. And it's gonna basically pull up submittals for each one of these. Makes, if you are doing commercial projects, you're gonna have the ability to build this all out in one step. Then whenever I come back in and I do your extended warranty verification, basically this is the information that I need right here. Basically site name, engineer, we're the distributor on it, installing contractor, startup date, install start date, startup person. In most cases that would wind up, being either me or your commission agent. And then you've got pressure test details, and you've got a little bit of room here to write out exactly what happened on the evacuation. Very important that we get this information. And then we wind up going through, and I wind up submitting this back over with some runtime, and we get you your warranty on your indoor, or on your all of your equipment. So at this point, we go back through, we do a global check. It's going to tell me all pipe runs must end with either. So we're going to go back over here to home, and we're going to go to design view. And yeah, I do have two over here that do not have any type of equipment added to it. So we're going to add end caps on these guys. Even though they're ball valved off, they still need to have end caps. And then we're going to go back over here and we're going to do the global check, and all checks are performed complete. So, it will, as far as recording this, we definitely, I believe we can do that. Okay, so this will go on genscocustomer.com. So it will be available to all of you. And at this point, I'd like to go ahead and open up, and if you guys have some definitive questions, we can get those addressed and get any answers. In a lot of cases, whenever I am doing training on this, what I'll do is I'll actually team viewer into your computer, and I will do kind of a personalized one-on-one training with these things. I do that with a lot of my clients here around the Seattle area. So if we've got any questions, let's go ahead and open it up. And if not, we'll go ahead and jump off and let you guys get back to your days. Aaron, do you have any input or anything that I might have missed?
No. What I would recommend, if you have questions, go ahead and raise your hand or type something into the chat.
Okay, so elevation. As we go in here and we look at main unit height is not elevation. It is a comparative height between the indoor and outdoor units. As we go and we set up the initial project properties, our elevation is going to be here under design conditions somewhere. If we go manual, altitude is shown right here. So, but based on location, we're at 6,600 feet. So there's your altitude versus elevation, if that makes sense. That is a good question that a lot of people don't get, because that will affect D rate. So I do appreciate that you brought that up. So I'm not seeing any other hands go up or anything go into the chat. So we'll go ahead and end this. And like Aaron said, we'll get this posted. and it will be available at any time. If you guys do want some one-on-one training, again, my name is Jason Phelps. My email address is jphelps@gensco.com. And yes, the builder will tell you if you do have too many bins, that's going to come up as basically a length error. So, but one of the things that I do talk about is what is considered a bend. And if you're brazing in a fitting, then it will be considered a bend. But if you are hand bending or anything along those lines, that's a smooth enough radius to where it actually does not see it as a bend. All right, so I'm going to go ahead and leave this open for a few minutes. If you guys want to jump off, you can go ahead and jump off. And if I have any more questions pop in, I'll do my best to answer it. But please, again, feel free to email me or anybody else in tech services. We all work with this program on a daily basis. So in a lot of cases, we do get stuck on, how we wind up running it and what we see as more often. So I might have overlooked some things that you guys need to see. Don't hesitate to come email me any of the guys in tech services, and we'll get any questions that you guys have answered. So anything else coming in, go ahead and pop that raise your hand button. Otherwise, we're gonna jump off, and we're starting to see participants kind of dwindle. So, like I said, I will hang out. I'm always available by email. Um, Happy to answer any questions that you guys may have.